we're going to jump into this pretty quick. So we got a list here of questions that have been asked over a period of time. So I thought it'd be easier to answer some of them, just do it this way, because there's quite a few questions and it would entail quite a bit of typing and stuff. And it seems like I answer the same question a lot of times for multiple guys. So I thought, you know what, let's just do a video. And since we're doing it live, I'm not going to break it up. So I got left rear, right rear, pull bar, and right front questions. So I kind of got them grouped up. So some of them were a little specific between what was going on at the time between me and that person. So I'll try to do it in kind of a generic question answer or question. I'll try to read the question in a generic way. One of the things that we do, I kind of like doing these. We're doing this live, okay? So it's unrehearsed, we're just doing it, So whatever happens, happens. So this is, I don't know, it's a little funner this way. So this is what we're doing it. So if there's some mistakes or whatever, you guys all get that. So if you have questions you want to ask, ask them, type them in. We're probably going to run for about half hour, so we're not going to try to overdo it. I got a dinner date, so we're not going to try to overdo it. I want to take Mama out to eat supper. So we'll start here. Left rear bind issues, car is slow to climb on bars, okay? So close the gap on split between upper and lower bar angle at full droop. Okay, shooting for 10 degrees, yes. So when you're at full height, now this may be a little different, zero index versus non-zero index. So if you're non-zero index and you raise the lower bar, you close that gap down, within about 10, 12 degrees, you are going to lose drive in the car doing this by adding rear steer. So if you're looking for drive, then but to reduce the bind in the car, increase that lower rod. Lengthen top bar on both left rear and right rear 2 inches longer versus bottom bar. So on some cars, they run a 1 inch split or they run heads up. Most of the cars out there, I'd say, 90% of them are probably on a 2 inch split. And that 2 inch split back in the day was 1715, okay? So, we're kind of all over the place, but yeah, it's a 2 inch split. This will free the car up. It'll take some drive out of the car. So some of this left rear was coming off a car that is extremely tight, tight race car. Lengthen top, oh yeah, I did that one. Utilize zero index options. Zero index options, open motor car may not be as good as crate motor car. So doing zero indexing on crate cars with preload and left rear is absolutely pretty good. Short track racing, zero indexing, maybe not, car with a lot of drive might just be better. Taking a standard index car and having some preload in it means it's going to be pretty tight. So, quarter mile racetrack, like they race in Illinois area, that would be relatively, a good setup. So, back to the zero indexing. If he was going to do zero indexing, it's moving the top bar back. So if we're on a 15-17 split, move the top bar back 1 inch, move the bottom bar forward 1 inch. Leave the bird cage indexed at 0. Starting bar angles at full drop. Okay, this was kind of a specific question that was asked. I should have skipped it. But, a non-index bird cage, we're probably talking 27 to, 35 on the upper and 10 to 15 on the lower. Bird cage indexing at ride height, okay? And bird cage indexing at ride height is, this is my bird cage and I'm straight up and down, which means, on ours, across the shock, across the shock plate, 80-20, there's an indicator spot on the back of the forelink. So it's 90 degrees to ground, 0. Okay, so to pre-index into the left rear, if you're doing a zero index, do not preload into it. Most of the time, we never really preload into it. It's maybe on a quarter mile racetrack, it'd be, we race a lot of 3/8 stuff in the slick. So sometimes in the slick, when you pre-index into it, on a standard setup, it wants to maybe make the car too tight, instant throttle too tight. So I'm okay with it, but I've never been a big fan of it. There are some guys that live and die by indexing. They're indexed in, indexed out. Yeah, it's several chassis companies have done that. I don't think it's as grand as some of them make it out to be, but it is a thing. If you're zero indexing a birdcage left rear, well, don't just run the birdcage at 0. You might even run it negative instead of positive, a little, to take a little more indexing away from it. This question was, I don't know if we should even bother with it, is need to improve left rear compliance, options. Okay, well, it depends on what compliance means. If you wanted to add drive to the car, shorten up your bar lengths. So, put a 1-inch split in instead of a 2. You could index in, preload on a standard deal. It's all going to build drive in the car. Slider options, angle in the slider, chain angle, topping the chain out, birdcage location on the axle tube, shock location on the birdcage, base valve, shock versus non-base valve in the gas environment, shock behind, spring behind. That's going to improve compliance if you're looking for drive. Okay, in some cars, like we have, a dealer car from the Midwest that doesn't need to be any tighter than it currently is, okay. But the drivers, I think, want it to be a little tighter than it is, but the car already struggles at turning. But they tend to race on more moisture as it slicks off. They need to turn better on the front tires. So doing some of that stuff when we said compliance, if compliance meant more drive, well then we're just getting ourselves into trouble. So keeping it free back there, car needs some drive in it, but it doesn't need to be so driven up that it won't turn. So when using zero index holes on birdcage, what limits my maximum chassis separation? Well, I think, of course, it's the chain, but I think maybe the question is what is my maximum? Because it ends in a number. What is my maximum chain separation? So, it's on a zero index. It can get up there, So like if you're 4.5, you might be 5.5, 6, 6.5. I've even heard guys being in that 7-inch range. Now, the problem with that number is it's not golden. So my number and your number are never going to match because we're not doing it exactly alike. So if I'm on a GRT and you're on an Impressive, well, there's no way we can measure chain drop and come up with the same number because we're measuring in 2 different spots. Okay, then guys all measure it different anyway. So even if we're measuring in the same spot, a lot of times I see that we're measuring in different spots. So quick example, a guy said he had 4.5 inches of chain drop. Well, it's clearly obvious by his pictures he had way more than that. So how he was really measuring it, I don't know, but you think this would be more of a simple process, but it seems to be a lot of different numbers involved in that process. So chain separation, it's probably around 6 inches to where we were probably 4.5 before. Left rear spring load, standard travel is 4 inches. Okay, I'm going to have as much as 5 3/4. So you can get, so basically he's on standard, he's on 4-inch split, can get out to 5 3/4. If you're not zero indexing, we limit the chain split because of the rear steer. So we kind of try to hold the car, you know, from oversteering the car. Okay, so long straightaway tight corner might get the car into trouble a little bit with the car trying to auto turn going down the straightaway. So we've limited, in the past, you know, we limited hiking the car to around 4.5 inches to keep the rear steer down. Okay. Nowadays when we index the bird cage and we get a lot more separation, well, we get a lot more rear steer. So we're doing things to compensate for the rear steer. Some guys will, you know, start the left rear back, so when it comes up to hike, it's not getting as much rear steer. Works good on a crate car because the car stays in posture much more than maybe an open motor car might. So, you know, we're kind of preload number, like if we're going to preload a soft spring 125, that preload number is going to be about 225 pounds. And that was the next question. Left rear spring preloads setup, start preload at 225. I mean, you're going to be in that 180, 150, 180 to 250 range, you know, and 180 to 225 might be a real good range to be in. You know, some guys do add preload to the car to put drive in the car. Some guys are moving lead. With preload, they'll have preload in the car and they may put a piece of lead on as it slicks off to increase the load weight, which I think is a good idea. Lead, weight on that tire, weight in that car, and I can't emphasize weight enough. You know, just about every car I look at, and several of them I've mentioned, are definitely lighter than what they were 10 years ago. You know, so I mean, you take a standard car in 2010, we would have not, you know, we were struggling to get, you know, bear weight at 2450 without driver. Now we're at 2250 without driver. So these are different race cars because they're much, much lighter, okay? And traction becomes much harder to accomplish because of the weight. And if you look at the weight, where did it come from? So where did we lose weight from? And we're getting off subject, but we're going to talk about it a little bit. I mean, where did we lose weight? You know, I mean, so is it sprung weight or unsprung weight? Because the tire, the wheel, you know, and like a guy said the other day, well, I'm on aluminum calipers. Okay, well, there you got a weight differential. But the tire, the wheel, the spindle, the hub, those things haven't changed weight much in the last 10 years. So, and for a lot of guys, they're still on, I mean, IMCA cars are 2250. So a lot of guys are still on a cast iron caliper. So the weight out there, the unsprung weight, it didn't change much. So it's the sprung weight. It's the weight that dictates how much grip we get has gone down somewhere around 200 pounds. So grip in the slick has become harder to get because we got less tools to get it with. So let's go back to the list. If using the left rear spring preload setup, start at 225. Okay, yeah, start at 225. See, I told you this was live. So, are there any standard roll steer numbers out there? I have 3 3/3 of wheelbase loss currently. Okay, rear steer. So yeah, we used to have some decent rear steer numbers, you know, but it really wasn't, you know, and it probably would have been 2.5, but it really wasn't very well, you know, documented or measured. So, you know, as we come with some tools to do this, we've also come with multiple ways to do it. So, you know, you need to check your car because let's say the left rear moves forward. You know, I seen a deal the other day. You know, they put the car down on the plate and they put it in rear steer. Well, they measured between a block and the plate and they said, okay, 1.5 inches. So we got 1.5 inches of rear steer. Okay, but they didn't compensate for the right rear. And to assume that if I get 1.5 inches movement on the left rear, I got 1.5 inches movement on the right rear is, you know, it's not just practical. Cars, I mean, they're not pivoting exactly off the center. Some cars do, some cars don't. So if you want to get a total rear steer, you're going to have to probably check both sides. So, you know, right now I'm going to say 3 inches, maybe that number. If you guys want to comment on some of that, that would be great because, but you know, here again, we have multiple ways of doing it. So, you know, if you do comment, you might get into a little bit total rear steer, left side only. Does the left side move more than the right side when the car goes into rear steer? Theoretically, you know, you would think the right rear goes back, the left rear goes forward, and it does look like on the racetrack that the left rear goes forward more. So in some of the cars, and especially, you know, I don't know if it's, you know, when you name a brand, I'm not saying this is good or bad. I'm just saying, like in a GRT, we've had, you know, and this is something I'd like to clear up in them chassis, because we've had more cars with different bar toe, you know, like the left side might be straight, there might be a lot of toe on the right rear, there might be a toe on both sides, or it might be toe on the left rear straight on the right rear. Okay, and I've seen where these cars are moving, you know, the toe in the car differently, you know, based on how they're set up. So, and this chassis, for an example, has a long, short, short, a long bushing, short bushing on the chassis side, and you see them flipped and in different configurations. So,
can you turn the mic up?
The rear steer, I can probably talk up.
Yeah.
Yeah, I'm going to do that because
it is up. Yeah.
Okay, I'll try to talk louder. So basically we're getting into right rear. So we have left rear, right rear, pull bar, right front. So right rear, it says on exit, the right rear does not feel into the racetrack, cannot pick up throttle. Okay, wants to fix this problem. Shock spring combo, exit on the right rear. So when we exit the car on the right rear, ideally going straight would be ideal, but it's not what's happening. So we're exiting the corner, but we're moving around that corner and laterally forward. Okay, so we're trying to load the right rear with that side load, but at the same time we're trying to separate the bars back there so the car is climbing. So we got to be really careful with, is there a problem? Oh, we got to be really careful with getting the car up too high, have too much climb in the bars, because then we'll lose that side bite, which I hate that term. We'll lose that load on the right rear tire that's keeping the car from just slipping the rear loose on exit. So it says shock spring combo is upside down, Schrader valve down, top of right rear spring is very high in the car. Okay, this will create a more free condition for the car. Okay, because, and a lot of guys will run their spring up in the car because when they turn it over, it wants to hit the rod down there. So they'll raise it up to get the bottom of the spring above the rod of the 4-link car. Okay, some cars on the right rear are really crowded over there. They're really tight. But when you, even like saying a 13-inch spring got the spring up and you're lacking feel on the right rear, is because there's not enough weight transfer. So our center of gravity versus our spring box is not right. So our center of gravity basically in this scenario is too low. A roll center of gravity, you know, as that weight rolls over, it kind of rolls into the spring like this instead of rolling down on the spring. Okay, theory, the weight transfers through the mount. Okay, whether this is the end of the mount and this is the spring, doesn't matter whether the spring's down here or up here. Theory. Okay, but every time you lower the spring table, the car moves easier. So the theory seems to be a little wrong. So we always say, you know, if you run like a 13-inch spring, you got the spring up, and you're on 200. If you turn, I mean, it's like running a much stiffer spring. Okay, sometimes almost impossible to get the load. The car needs weight on the right rear. So for years, we've put 25 pounds lead over there in the slick, maybe even 50 pounds of lead over there to make the body roll over, make the car load that tire in the slick, because the car lacks that motion, you know. So spring up, spring down, 16-inch spring versus a 13-inch spring, you know. So spring up and a 16-inch spring kill lateral load to the tire on the right rear. So if you are struggling with that load, then, you know, getting the spring down in the car by maybe making an extension to move the top down, screw the bottom cup down. Okay, that's one thing. You know, maybe going to a 13-inch spring, but the other thing is making sure that the weight in the car, the weight sitting on 4 tires, and this is where we're getting into trouble when we're 2250, because our excess weight is so minimal, it's gone. Okay, it's just gone. It ain't even minimal, it's gone. So we can't move weight off of one tire to the other tire without hurting the tire we're moving it from. But we need to make sure that the right rear carries the proper load. So if the car isn't carrying the proper load at ride height, then the car is always going to suck. Okay, so it's going to require moisture or a good tire. So IMCA guys, you know, you definitely need a good load. UMP guys probably can get away with it, you know. I'm sure there's places where UMP, you know, hasn't got great moisture. You know, you get out in that Ohio, Pennsylvania area, I'm sure it's slick. You know, Virginia, I'm sure it's slick. You know, Florida, I'm sure it's slick. But you still got a really good tire. Okay, so spring load, got to make sure the spring load is right, correct. If you don't know what that spring load is, then you need to probably call us. You need to get in on the team deal so you can learn these things. It's very difficult to explain it to every single person. Okay, but spring load, we probably need to have that right rear loaded up, you know, 350 pounds, 400 pounds. Car needs to set on the ground with the correct amount of load on the right rear tire. If it's not, then the car's never going to be as good as it should be. Okay, so here the question was, current measurement is 20 1/4 center to center at ride height, load is 300 pounds, 13-inch spring, 13-inch 200 pound spring with the spring rubber. This is with a 5-degree index into the spring. So here's a deal where they got the birdcage index into the spring on the right rear to gain more spring load. And they're on a 300 pound number, which is probably a little on the low side. The spring rubber doesn't give you as much static load as it does down number load. So in this case, the car should probably have more static spring load in it because its dynamic load is probably too low too. So it needs more load. Okay, now how do you get load in the right rear? A lot of guys, and I think we're learning, but a lot of guys go over and put turns in the right rear and call it done. It seems like the more we talk about it, the more guys are coming around that are doing it correct. In order to get load on the right rear, there's only 2 ways to get load on the right rear. Add lead to the right rear or put turns in all 4 corners. Okay, so that's the only 2 ways I know. I'm sure there's some smarter guys out there that have, but adding preload to one corner does not put load on another corner. Okay, so let me explain that. And we're going to do it left or right front. Okay, we're going to roll a car up on the scales with 40 pounds of bite on a 200 pound left rear spring. And the right front weighs 450 pounds. Okay, so if I put wedge in the left rear, my right rear scale number continues to get better. Okay, but you're still racing a 450-pound right front car. Okay, so just because the car looks better at static doesn't mean that the weight is increasing in dynamic on the right front. So if I come in here with a 125 preloaded at 250 and I'm sitting down on the scales and all of a sudden my right front says 525 and I'm like, you know, happy, but I'm still racing a 450 car on the right front. It's only transferring weight in static, but not in dynamic. So you can't preload car to get numbers. You got to add lead. You got to put turns in all four corners. You got to move the existing weight in the car by turning all four corners, or you got to add lead to the car. So, I mean, the only way I see doing it is add lead. Benefits of adding a movable right rear shock mount to give more tunability to the right rear angle. Yeah, I mean, I see cars that can lean the right rear in. You know, if you was in a slick condition standing up, say at 5 degrees, and you rolled her over to 18 degrees in the slick, you softened that spring rate up, okay? And yes, that may have moved the spring table down in the car a little bit and allowed the weight transfer and the roll to get over on it. And maybe it added, you know, 30 pounds to the right rear, 50 pounds. And that was enough increase in tire load to make a feel for the driver, which maybe, you know, took the car from I can't feel it to I can feel it, but it's still good enough before. But if I can't feel it, I ain't going, you know. So I'm not a big fan of all this because I've seen where guys have moved it, you know, one hole, and then it's this day and night difference, okay? And it's not that type of an adjustment, but, you know, so they go on about it, but then you do other things that should have been highly noticeable and nothing, you know? So I haven't done it on data. Data doesn't always mean that it's going to be good in the driver's seat, okay? So data just means that if we were in position A and now we're in position C and the numbers change, you know, you got a hardcore, does it go up, go down? Just because the number increases doesn't mean the driver got more feel. Pull bars. So, okay, chassis calls for a 1,200-pound spring preloaded at a 1/2 inch. Wants 2 inches of travel. When I set the pull bar up this way, this will collapse the spring to 4 inches of travel. Okay, I have a video of this happening. After trying multiple things, multiple spring rates, I had to add a rubber puck in order to limit the travel. Reason why is unclear to me. I feel there's room for improvement in this area. Absolutely. So, in a moisture environment, travel in the rear suspension is okay, especially on a UMP tire. In moisture, travel on the rear end of the 9C8 tire is you know, not as good as that, you know. So in a UMP car on that tire, you probably never notice the imperfections of what's going on in the rear, where it's bearings, rod ends, whatever it is. You never really notice that, you know. But in a IMCA car or when you're on a harder tire, even in the moisture, you might notice it. Now, as it slicks off, then you start noticing it. You can't get away with that much travel. It's just not going to work, you know. So you got to limit the travel. Limiting the travel. So I see cars and they say, "Oh, I'm 2.5 inches in front." Well, when team members send me pictures, it's like, that ain't 2.5 inches. I mean, it don't look like 2.5 inches. So I'm assuming that it is a little difficult to measure, but you know, from center line of the axle forward, we need to be out there a little ways, and maybe 3 inches ain't enough. But the closer we get to center line, the more pull value we get. The more we get behind, the more pull value we get. So in order to load a tire 4 inches on a 1,200-pound spring, better have a lot of tire you better have a lot of racetrack, because when it gets there, it's going to put that load to, and we're on a 450 pound car. So when it gets there, it's going to put that load to the tire. And if the tire can't and the racetrack can't hook together, then the tire's going to spin. So load it up some more, it just spins sooner. Okay, so this whole thing of, you know, trying to make the pull bar make traction that's not available, that's not how a pull bar works. A pull bar takes torque from the motor and spreads it across the tire over time. So I can do it quickly, or I can do it over a couple seconds. Okay, so you need to understand how much travel you're getting. You need to understand how much load that travel produces. When you get into a more complex pull bar, then it becomes difficult to understand the load number. Okay, so you need to understand that load number. You need to figure out how much your tire and racetrack can endure, and whether you can move the pull bar back on the rear end, or if you need to move it forward. So rule of thumb, the slicker it gets and the harder the tire, the more forward it needs, and the less rate you're going to be able to apply to that tire. The bigger the tire, the more moisture, or the better the dirt quality, you can start moving it back. You can start loading it up harder. Just kind of a basic rule of thumb. Starting position for pull bar on quick change, 2 inches ahead of axle center line. Standard pull bar height. Can I get existing measurements once I know where to measure from? So center line of axle, okay, forward. So, you know, it would be, you know, you see some, you know, so it's kind of like if you took the pinion angle out and you measured straight up that bolt on the bell, you know, over, that's your, you know, so now we start rolling it this way, we gain a little more, you know, but we need to look at that. Two inches in a slick environment is probably borderline on, you know, how far forward it is. When the pull bar is in front, it tends to make as much movement as the tire and the racetrack will allow. Okay, so as you move it back, it'll gain more. So back to what that one question, you know, where he put the puck in there, that's probably, you know, the best thing going. You know, it's basically what our pull bar is. It's a spring rod with a puck in it, and, you know, we dictate how quick it gets to the puck, and it makes, you know, a certain amount of rate. So we can adjust the rate value, and we can adjust the time over distance over time, and it's very good for the car. So pull bars don't have to be highly complex. They're becoming that because it's more easy to sell. It's just a spring, a biscuit, works pretty good. Standard pull bar configuration works pretty good. So if you need, we'll probably cover a little more of it. You know, we'll do some type of pull bar deal and probably cover a little more of that. Right front, I need to get the car to start diving more, or I'm sorry, I need to get the car to start driving more off the front of the tires. Okay. So this is true. You know, I feel like, and there's some questions there, but I feel like in an IMCA car, maybe them guys have done a good job of getting the car on the front tires, getting it to turn. You know, automatically when we went to the 604 crate, this increased the front of the car's performance ability tremendously. Okay, so say you're on a UMP tire and an 800 horse motor, you know, 750, you can spin the tires. Okay, those cars a lot of times are raced on the rear tires, and this particular guy in this question, and I know this question, is trying to get off the rear tires. Okay, they've been racing on the rear tires over there, and there's some guys over there that are extremely good at it. Okay, now you're starting to see some guys in that market that are much better than everybody else about racing on the front tires. Okay, so as the track slicks off and the rear tires become more difficult, they tend to shine more. Okay, so we've seen this all through, you know, the Hell Tour last year, through the Summer Series. certain people really shined in the slick. This means they are better on their front tires than they are the rear tires. Okay, racing is going that way. Most of the country is there. Good UMP tire, good quality dirt guys aren't there, but we're headed there. So you need to you need to turn on the front tires. Okay, you need to propel the car forward on the rear tires, and the grip level between the two needs to match. So if we have a ton of rear grip and little front grip, we're just going to push the tires. We're never going to load the front tires enough to make the car turn. So thoughts on moving engine to the right. Okay, this has become a new hot item. Moving engine to the right increases the weight on the right front tire, but then at the same time, most of the people that are doing that are also doing the same. Let's move the longer lower. So they're running a right front longer lower, moving the tire out. So you got to determine what you want: tire load or longevity on the tire. So if you want to load the tire up with a number that creates grip, or do you want to lay on the tire longer, okay, with less grip? So that's what you got to determine. Wheel offsets, longer lowers, moving the engine over. Moving the engine over is probably not a bad idea. I mean, it's a lot more work than just adding lead to this, the car. So every day for, and this will make it official for today, every day for the last 3 years, I've had a conversation with somebody about adding lead in front of the motor plate, okay? And most of the time I have to bend their back to do it, get it up there, okay? So if you're willing to move the motor over to increase load to the front, adding lead would be a little simpler, and sometimes because it's below, you can get it below the spring height, spring table. Okay, the motor's setting highly above the spring table, so moving it over is a positive and a negative both. So you got to deal with both of them. But in general, would probably be a good idea. Is there an XYZ dimension out there for engine location in a car? There's not. Here again, we do the typical thing. We have a rule, and the rule says we have to be 72 inches from the motor plate to the rear end. That's the rule in a lot of classes or series for a modified, so I don't know if it is for everybody, but what happens? Boom, we go to 72, which means we got our motor back as much as possible. Back in the day when we were trying to make, all this tons of rear percent, that's what we did. Okay, but, we're living in a different world now. So if we're trying to hook up an 800 horse motor, we may not need rear percent, but we need rear weight. Okay, and when we gain rear percent or rear weight by killing front, then we're robbing Peter to pay Paul. Well, we're hurting ourselves in the front and helping ourselves in the back, but helping ourselves in the front is hurting ourselves helping ourselves in the rear. It's hurting ourselves in the front twice. So we're gaining one, hurting twice. So the car has become much, much tighter. So XYZ dimension, there's not a golden, I don't think there's a golden rule. The chassis guys do what they do. And, it's more of a center line deal. And we need to do a video on that because I see some confusion between center line in the front and center line in the rear. And how to obtain it. So, we're going to do a video on that. We've developed some tools which I felt like, I don't know if they are marketable. So this is a question for you guys. It allows you to come off your motor plate to pick up some dimensions. And in some cases, it's common stuff. And I'm the first to say nobody buys common stuff because you all have it, but it's kind of like we're going out to eat tonight for supper. We could go home and cook supper because I got food at home, but we want to go out and eat. So we're going to pay somebody to cook our food, and this has become more of a way of life for a lot of people. So we're paying people to, we're paying for race car parts that are already done. We don't have to fix them or work on them. We're paying for setup tools that are we don't have to build. You know, for years we built our own setup tools because nobody was building, because most of the guys would build them, you know. So nowadays guys want to buy them, they don't want to build them. So this is a tool that I'm sure there's a group of guys, or a large group of guys, that would rather buy it than build it. It's done, they don't have to mess with it. Third time's money. They want to get in the shop, they want to you know, we got less time nowadays too, so they want to get in the shop and they want to get the car up on pads and get it measured out and be done, you know. So they don't want to spend, you know, half a day building tools that may or may not work like they need to. So we got some tools. Team guys, you're going to get hit up with this after the first of the year really hard, because I'm sending you rear end squaring measurements that you need to take to make sure the car is correct. So had a customer the other day measure his car up, and lo and behold, his right front is way off. So this is something that he didn't know was going on. I'm not even sure. I mean, it come from the chassis guy probably this way, and I'm pretty sure he's raced the car for a couple of years, doesn't even know it. So lead ballast ahead of motor plate. Okay, that was the next question. I told you this was live, so I could have read through the list, but lead ballast ahead of the motor plate, absolutely. Why not? I get it. You guys have done a great job to get your cars to 2,250 pounds. But the old saying, and the old timers know this, the old saying is make your car as light as possible so your car is as fast as possible. But it's only going to be that way when you add weight back to where it's needed. Okay, so we trimmed the weight off the, you know, the car, and basically we were supposed to be trimming the weight off of the unsprung, the stuff outside of the spring box, the stuff that we have to control the movement of. Okay, all that stuff has leverage on the spring. The heavier it is, the easier it moves the spring, and the easier it moves the spring, the harder it is on traction. So if them components got light and the box stayed heavy, well, the car would make great traction all the time. But instead, our box has gotten light, and our wheels and our in-sprung weight stayed relatively the same. Okay, so it's become much harder to make traction. Okay, lead in front of the motor plate, absolutely. Where you put that lead in front of the motor plate, 100% important. Okay, being right front, static wheel weight. Current wheel load at ride height. Okay, so as the car's gotten lighter, scale numbers gotten lighter, and one of the not benefactors, but one of them that's taken the biggest hits, the right front. So we do need to get the right front. You guys need to start looking at the right front. Guys that say scale numbers are no longer important might miss out on this. If you got a tight race car on entry, there's a reason why. So you need to start putting your car back on the scales and looking at that. Team members, you know, you've got questions asked, we can get an update on that. It's something that in 2021, you guys as team members are going to be paying attention to, because you guys are going to be scaling your cars, maybe not weekly. You can use load sticks weekly, but you are going to scale your car. You are going to have to know where your car's at. You know, it's, if you want a good car, if you want to go to the racetrack with the best opportunity to win, then you're just going to have to do these things. If you don't want to do these things, then that's up to you, you know. But it's going to hurt you, you know. So it's going to make our job of getting around it much harder. So we're going to scale our cars. We're going to pay attention to wheel load numbers. We're going to pay attention to static numbers. I know. We don't race in static, so why scale in static? Okay. Well, if you don't know the answer to that question, that's why you need to be a team member, because you need to know the answer to that question. Why do we scale a car in static? Because there's things we need to know. Okay, so relationship between jack screw and center line of spring. Okay, the relationship of the jack bolt. Okay, so this is the last question. So his question is his jack bolt is not in the center of his spring. So his top jack bolt isn't in the bottom of the spring cup, okay? And some of the aftermarket stamped arms are probably a little worse about this than I would have thought the aftermarket fabricated arms, okay? But, you know, just because you got a fabricated arm doesn't mean they put the spring cup in the right spot, okay? So, yeah, so, and it's not so much the spring cup. Sometimes it's the spring cup. Maybe when they welded it in, the rod ends in, or nowadays I think you can get the lowers with the rod ends loose, which means you can start putting caster in the bottom, okay, where you never could put caster in the bottom, okay, but this means things are moving around, you know, and then theoretically I think you're supposed to weld them up. So there could be a lot of, you know, the car being off in the lower, okay, but that doesn't necessarily mean that when they welded the jack bolt in, that it didn't get canted or moved or whatever. So, you know, when the jack bolt's not in the center of the front spring, then there's side load created between the jack bolt and the mounting point of that bolt. So whether it's a bull nose end, a com ball end, a sloppy hole, whatever it is, if there becomes load there, then it's going to change how the car gets on the right front. Okay, so if you can get your, you know, back in the day when we put Nova lowers on a metric car, that always had the spring real bowed, okay, and that had to be, it was horrible for the spring, and it had to be horrible for consistency on load. And nowadays, where we're getting in softer and softer springs, you know, it's just, we can manipulate that spring much easier, but that doesn't mean the load gets better, you know. So, you know, run your car through a cycle and see where it is in relationship, you know, where the jack bolt is in relation to the spring cup. And we want to try to keep it pretty centered up. If it's off-centered, you know, you may have to, you know, consult your chassis guy or, you know, a fabricator, or fabricate it yourself. You might want to move the bolt angle a little, or you might call your chassis guy and ask him why it is like this. Okay. Now I know I just made a bunch of chassis guys maybe mad because they don't want all these guys calling with crazy questions. Sometimes it is what it is because that's the way they designed it and it's been working, but sometimes it needs to be fixed. So that's pretty much the questions that I had. Gotten some questions over time. You know, I think we want to do, you know, real quickly, was there any questions anybody asked?
Chad Smith said, if you have a heavier motor, would I want to set it higher or lower in a modified?
Okay, here's the problem with high. So let's say, you know, this is our car right here, okay, and we're wanting, and the motor's sitting up here, and we're wanting to transfer weight to the right front. When that lateral force, when that momentum goes that way, we want to transfer it, okay? So the higher the weight gets, theoretically, the easier it moves, okay? So let's put that weight clear up here, okay? Now when that weight goes, that weight's not going here, it's not going here, it's going here, okay? So it's being cast out like this, and it's pulling not only the left front, but the right front up off the racetrack. So weight in the car needs to be maintained as low as possible, okay? Getting your weight to roll is tough. Now, in the front of the car, there's a center of gravity and a roll center, okay? And same in the rear, okay? In the front, those 2 points will never get to each other, but the closer they get together, the harder the roll becomes, okay? It's logic, because we're moving our weight down, so when we move our weight up, it rolls easier, okay? But we got to be careful. So when the guy puts, you know, weight in the car and it's high in the front of the car, it can hurt traction to the tires, okay? It will roll weight transfer, but you can't get carried away. So heavier motor. If you got a heavier motor, yay for you, because you one step ahead. Okay? If you got a Ford motor, even better, okay, because they're heavier, okay, but they don't need to be setting up in the air a ton. So Heavier motor is not a bad thing. You know, anytime a guy says, well, I'm on a Ford motor and I think it's a disadvantage, no, it's not. It's an advantage. So,
Is a Gary Donaldson, is a drop cup to create lower spring table a myth?
well, there's a big argument with that. We had that conversation today. So there's definitely people that believe in that 100%. The reason I don't is because where the cup and the spring meet hasn't changed. Okay, the upper, and this is in an upper cup. The spring movement is fixed here, moves down here. Okay, so by moving that point, that focal point from here to here, didn't increase the spring load. It decreased the load the spring creates to the jack bolt. Okay, so if there's bind, you know, pin misalignment to the spring, okay, which is creating bind, so your comm ball gets 18 degrees of movement. Okay, if you need 25 degrees of movement, then you're about 7 degrees short, and that 7 degrees is going to cause extensive load to the top part of the spring, which may cause some inconsistencies in the spring's ability to collapse, but it's definitely going to overload the ball in that spring bucket. By lowering it down an inch or two, you decrease the angle, which allowed you more travel. Okay, so you can have a little more misalignment. But there's simply another problem. The jack bolt diameter starts getting into the cup. So you can only open up the hole inside the cup so much. And so you can only lower the ball so much. So there's only so much you can do there because you're limited. Okay, so it doesn't increase. I've got them. I couldn't sell weight jack cups because you guys wouldn't buy them because we didn't have a drop cup. Okay, I don't really feel like we sell that many drop cups. You know, I mean, we got them. We got them. If you want them, if you want to run them, run them. I did enlarge the hole because I seen where other cups, where the jack bolt was rubbing the edge of other cups, and they were getting hung up on the threads, and I mean, enough so the drivers could fill it in the cars, you know. Maybe not a 3,000 pound stock car, but definitely in a 2,200 pound modified, they could feel it getting hung up. So I say myth. You know, I say myth. You know, if you want them, we got them. If you like running them, run them. When we run a drop cup before, when another company made a drop cup, nobody screamed how good they were, you know. So I don't know why all of a sudden now they're just, you know.
Derek Losh said, you mentioned getting away from racing on the rear tires with big horsepower as well as some dominant UMP cars during summer nationals. These same cars were carrying the front tires 8 to 10 inches off the ground and slamming the cars back down on entry. What are your ideas on where the additional and faster weight transfers are coming from to a point that upsetting the chassis to transfer weight is not a big issue?
Yes. Good question. Good question. Good read there, hon. So I'm going to make sure I understood this all right. So them cars were transferring a lot of weight, okay? You know, some of it's in that massive amount of pull they're getting in their pull bars, okay? A lift arm car is not going to transfer as much weight to the rear tires as a pull bar car is, okay? The reason that we're seeing more air under the front tires is because the front of the car is getting lighter, okay? The car's 200 pounds lighter than it used to be. I mean, 5 years ago, you know, maybe 8, you know, we've trimmed off, you know. I mean, I got guys that are rolling across the scales 10 pounds heavy, and they're 200, 230 pound drivers. Okay, so, and I mean, 230 pounds is not a big guy. I mean, not today, I mean, it's not a big guy. But what I'm saying, when I emphasize that, is their cars are 2250, you know, and as I said, we couldn't do that. So we're creating when we create rear drive 1 point, we decrease front grip 2 points. Okay, so if like I build a grip calculator, and you go through and you enter all this information in, you know, motor weight, motor placement, spring rates, you add all this information up, and it tells you your grip relationship between the front tire and the rear tire. Okay, well, you can have a split in it, so you can have more grip in the rear and make the front work, but you can't have a lot. So you got to put the tires on the ground. Starter number one. Okay, you got to have weight in front of the car to hold the car down. So you may have to modify your pull bar mounts. You may have to modify your pull bar load. You may have to modify how much your car makes grip. Okay, what did I say? Center line front versus center line rear. Okay, pull bar, center line front and rear. Total weight of the front of the car, spring rate in the front of the car, rebound in the front of the car. UMP guys are running more. Hey, just because you're running a ton of rebound in the car doesn't mean it's right. Okay, so because I can just pick the front of the car up, and I can pick it up, and the rebound can hold the tires. Yeah, I slobbered on myself. Can hold that in the front of the car. So we got to have grip on them front tires. We got to race on the front tires. I don't know if that's really. I mean, if there's moisture in the cushion, I mean, there's guys over there that are phenomenal at racing on the rear tires, you know. And I heard a lot of complaints last year about guys beating them in the slick. Okay, they weren't complaining about how their car was in the moisture. They were complaining about how their car was in the slick. Okay, you know, I tell this story all the time. We was at Tri-City, and there was a guy running the bottom, and comparing him to Mike Harrison running the top, I mean, Mike and a lot of other guys I don't, you know, that were there, you know, big name racers. I mean, they looked extremely fast, and the guy on the bottom was just tooling around there, but they couldn't catch him. Okay, and then Mike got up there, and Mike finally ran him down and did beat him, and Mike won that night. It was about 3 or 4 years ago. But that guy should have never lost that race, you know, and he was a full-blown demonstration of somebody racing on the front tires, and he was doing it with a lot less speed. Okay, he was doing a great job of it, you know. So he just didn't happen to win that night. I think he did run second, but we got to get on the front tires. We got to make the car turn. You know, if you don't understand, it was Darren, right? Darren Lausch.
Losh.
Yeah,
Derek.
Derek. I'm sorry. So if you don't understand these things, call me. You know, text me on Facebook. You know, we can talk about these things. There are things that we can do to make a car have better grip in the front. First, we got to put the tires on the ground, keep them on the ground.
Brian Hansford said, what do you recommend on a street stock as far as rubber bushings versus monoball rear arms?
Hey, there's some advantage to rubber bushings, okay? And so the problems I've seen with the rubber bushings is the more movement you get in them, the more they break. Okay, so in a lot of classes, they're required to run a rubber bushing. So you have to make a rubber bushing car work. Okay, if you can run a monoball rear back there, then you better be running it, because it's going to give you more steer in the car without really any concerns of it breaking. You know, so you can knock the vulcanization of the rubber out of them bushings if they got a lot of move in them. You know, so you know, guys do stuff. You know, there's a bunch of rubber bushings being made out there that stick very well, but if you do something to and then they do, you know, different front halves, rear halves, to make the car have more rear steer. So if you can run the comball deal, probably run the comball deal, because it's going to steer the car up. Make sure you keep them clean, because it's going to bind the car up too.
Clay McWilliams, is there an advantage or disadvantage to running a progressive right front spring?
Well, there's an advantage to it, but I don't know that it's legal. So, I mean, the advantage of it would be to allow the car to travel down through its load, its travel easier, and then produce a load at the end. So a very progressive spring rate would be very ideal for what we want. Kind of hence a soft spring bump stop car would be progressive spring, okay, unlike a spring by itself. So I think some of them guys in, you know, the open motor stuff, North Carolina area, in that area, maybe can run some cheater stuff, okay? Because I believe UMP does not allow a progressive spring. I may be wrong on that. If I am, comment if we're wrong on that. But a bump stop soft spring is a progressive, so it's what it's what you want, because you're going to build the load you need. So there's a real issue in a modified versus a late model. So everybody wants to think, oh, I'm going to be like a late model. Well, you know, problem number one starts right on the right front. You got a spring here, and you got a shock here, and you got a tire out here, okay? And this is springs clear out here by the tire on a late model, okay? Huge difference. So if you can't understand that, you need to understand that. Big problem. So you can't always make a modified or late model because this tire needs grip. So that's what I said earlier. You need to decide what you want. You want grip in the tire load, or decide that. One's good for turning, and one's good for turning in the moisture. So, yeah, I kind of forgot what his total question was, but
is there an advantage or disadvantage to running a progressive right front spring?
Soft spring, bump stop, absolutely. So what you got to do is spring will get you to car in posture, bump stop will build all the load you need. Plus the bumps out here near the tire, so the load ratio is much, much better. If you're a team member, you will be privileged to a calculator to put that information in at the first of the year, so you can see how a tire makes load with a bump stop, with a 1 inch longer lower, with a 500, 550, 600, whatever, with a 1 inch, 2 inch, 3 inch offset wheel. Okay, then you can determine whether this is what you want to run, if you want to run tire load or tire time. So if you want to put grip to the tire, or if you want to spend time on the tire, okay? But when you spend time on the tire, you're going to spend it with less load number.
CJ Springers asked, if you have a good 2-link modified with no spoiler and switch to a track that allows a 5-inch blade, is there any changes you'd make before hitting the track?
Probably going to have to free the car up. So if you've been racing on the slick, you know, the only cat I've ever worked with that could go, I mean, qualified second one night with no spoiler, qualified first the next night with a spoiler, was Strickler, you know, and, you know, showed up at the Ice Bowl with no, that's probably not going to happen for most of us anymore, you know, but showed up at the Ice Bowl with, you know, according to the rules, and everybody else had a spoiler, you know. So he qualified very good that night with no spoiler, you know. So going place where you got a spoiler and you've been racing without a spoiler, you probably have a tighter race car, especially on a 2-link deal. Then you throw a spoiler on back here, it's going to make it tighter. So the car is not going to turn on the front. So back to Lauscher's, hey, you want to knock some of that? You want to knock some of that, take spoiler off. You know, so yeah, you probably have to free the car up, get it back on the nose.
That's all.
Okay, so we'll upload it to our YouTube channel so you guys can view it later. Well, a little longer than I'd hope, but I apologize, you know, because I want these videos to be very educational, but I want them to be.
Can also rewatch on Facebook.
Yeah, you can also watch it on Facebook. I want it to be, you know, I don't want it to be boring, you know. So I'm not going to say I'm the most entertaining speaker in the world, but I do enjoy doing it. It's been helping guys. I can tell by the phone calls we're getting. You know, so guys, you're doing your work, you're doing your homework, keep watching the videos, keep asking questions, because no matter what the question is, it just gets better, you know. So I mean, oh yeah, absolutely. I am completely horrible, and I know by now we probably lost these guys. I'm completely horrible, and I apologize greatly. You know, I love these things. These are very cool. Got some stickers, got this little hood. You know, I mean, you know, I want to win races, but, you know, sometimes you like to look over there on the wall and remember why you're winning races, you know, and without stuff like this, you know, you don't ever get to do that, you know. So, I mean, I appreciate it, but I am the worst at, and you know, and I'll explain that, you know. So Gary, I really appreciate it, you know. These things are cool. I've got, you know, a fender or a door over there. We got a little race car back there, you know, and I got a hood. So I think this is really cool. Now this is the one that gets me in trouble, and I apologize. Corey Baker, I love you, buddy, and I appreciate what you do. I appreciate who you are. And the first moment that this book showed up, I should have got on Facebook and thanked you. And I kept thinking, oh, I'm going to do it in this video. And it just got pushed out. So Corey Baker is keeping me educated in books. I haven't even got this one home yet to read, but you know, it means a lot. You know, it means a lot to me. So, and I apologize. Don't ever think I don't. You know, I mean, this means the world to me. You know, so we're building a family. You know, a family of racers. This is part of our team. This is what it's all about. You know, I mean, we're getting closer to people. We know people. We try harder. They try harder. It's a group. That's what we're doing. You know, and things like this, you know, I mean, it builds a bond between us, you know, so I really appreciate it. I apologize for, you know, not saying something earlier, but, you know, for you people that'll never meet Corey Baker, you're lost, because he is one of the highlights of racing in the Midwest. Him and his brother race. They have a team. They sell parts in the Nebraska area around Lincoln. They have a sport mod program that's very good. They have a shock program that's very good. He's one of our builders. He's not our only builder. And, you know, I'm going to do, really, I got a couple of guys that are working hard. Corey's one of them. Russ Rinwald's one of them. If I am trying to name the guys that I need to name, I'm not going to get it done. So if I know I missed your name. Don't be offended by it, because I can't do that. That's what I suck at. So, but those two guys in example have done an extremely good job. You know, we're putting some guys on in the UMP world. Tommy Shepard. You know, looking for, you know, people in them areas that want to be shock builders. If you want to be a shock builder, you might get a hold of us. But I want you to understand that I'm not like some of these big companies that you know, because I learned the hard way, and I think we've perfected a lot of that. So if you do it our way, it makes it a lot simpler. But you gotta do it until you figure it out. But you know, guys like Corey Baker and them, I mean, they got a great program going. We might do an open house up there. Russ Rinwald, it's got a great program going on. Builds a car. It's a great car. And they have great results, you know. Their biggest disadvantage might be it's on a smaller scale, and people don't notice it as much, but I'm sure the guys they race against notice it, you know. So you guys keep that up. Keep up the good work. Again, thank you guys for your love, you know, for our family, you know, for what you do for us as a couple, as a company, you know. You know, this is date night, and you've got standing behind the phone there. You know, we do that because we want to do this, you know. So we appreciate it. So I don't know if that's going to be the end of it, you know. If you guys got ideas, let me know. You know, next week we're going to be 3 days. We're going to be Thursday, Friday off for Christmas. We're going to come back the following week. We're going to work 3 days, be off New Year's Eve, New Year's Day, which I think is, again, Thursday, Friday. So a couple 4-day weekends coming up. Unfortunately, I'm going to get to work a good part of it, but that's what I do. So if you guys got ideas, you know, we're finishing up some new product stuff. Got a new product for Gary Donaldson that we're introducing into the line this year. Revamping some stuff we've done to make it better. Catalog will be, we're COVID. I don't even say it right. How do you say it, hon?
COVID.
We're COVID behind. We're China virus behind. Not only in production, but in the catalog, you know. So it's coming. New products are coming. Things are good, looking good. God bless you. We love you guys. So we'll see you next time.